Hi students, welcome again to our physics class. In this class, we are solving different questions which seems to be difficult to students. We are picking some topics in Form 4 topics and we solve different questions. Also, we are passing across different nectar questions to see the questions related to a particular topic in order to impart a very clear knowledge to the students and provide a simplicity way of solving different questions. We started with the topic of wave and we ended somewhere. Today, we are going to finish up on discussing the part of beat and resonance. Welcome to our class. Question number 1. The beat frequency of two notes of nearly equal frequency is equal to 6 Hz. If one is loaded with wax, the beat frequency becomes 4 Hz. This is the beat frequency before, this is beat frequency after loading. Now, to the data given, you can say data given, we say beat frequency before loading. You can say FO, beat frequency before loading equals to 6 Hz. This is the beat frequency before loading equals to 6 Hz. If one is loaded with wax, the beat frequency becomes 4 Hz. Now this is the beat frequency. Beat frequency after beat frequency after loading. Beat frequency after loading, say FA equals to 4 Hz. Equals to 4 Hz. What is the frequency of the other note if the frequency of the loaded fork is 250 Hz? Now this is the frequency of the loaded fork. Frequency of the loaded equals to 250 Hz. What is the frequency of the other note? Say, let the frequency of the other note be F1. Also, let the lowest frequency lowest or lower frequency, can call it F2. Lowest frequency be F2. Lowest frequency be F2. Lowest frequency F2. Now we say the frequency, let the frequency of the other note be F1. Now if we take the frequency, we say before loading, we say F2, F1 must be greater to F2. Frequency of the other note must be greater than the lowest frequency. Now the difference in frequency gives a beat frequency. Now frequency 1 minus frequency 2 equals to beat frequency before loading, equals to beat frequency before loading, equals to beat frequency before loading. Now frequency 1 minus frequency 2 equals to frequency before loading, beat frequency before loading equals to 6 Hz. Now we can call it as equation 1, this one. After loading, because loading reduces the frequency. Now, after loading reduces the frequency frequency 2 must be greater than the frequency of the loaded fork. Frequency 2 must be greater than the frequency of the loaded fork after loading. Now, difference in frequency gives bit frequency after loading. Frequency after loading. Now, frequency 2 minus frequency of the loaded, this 1 Hz equals to frequency after loading, which is equal to 4 Hz. Now, we take this one to this side. Once it across the equal sign, it will be positive. Frequency 2 will be equal to 4 Hz plus 250 Hz. Now, frequency 2 will be equal to 504 Hz. Now, this is the lowest frequency. This is the lower frequency. This is the lower frequency. This is the lower frequency. Now, we say from, if this was equation 2, we say from frequency 1 minus frequency 2, which is equal to 6 Hz. Frequency 2 already we have got, which is equal to 254. Frequency 1 minus 254 Hz equals to 6 Hz. From equation 1, we can substitute this value to the equation 1 in order to get the frequency of the other node. Now, frequency 1 will be equal to 1. This one, to across the equal sign, will be positive. It will be equal to 6 Hz plus 254 Hz. Now, frequency 1 will be equal to 10, 6, 2 Hz. Now, this will be the frequency of the other node. Now we say therefore, frequency of the other node will be equal to 260 Hz. Now this will be the answer. What you have to know, the difference in the two frequencies gives a bit frequency, but loading always reduces frequency. This was question number 1.